Okay, so we continue. So the probability distributions that we're going to look at under continuous variables are the uniform. We'll start with the uniform distribution. The uniform distribution, the exponential distribution, and the normal distributions. So these are the common continuous probability distributions. Okay, so let's start with the uniform distribution. Okay, so the uniform distribution has a rectangular shape. Okay, so it is given by that. So there you have your PDF, and there you have your variable x, and you have A, B. So this gives us a rectangular shape. The PDF is just given by 1 over B minus A. Okay, so the B and the A are our intervals. Okay, so this is the PDF. Okay, A and B are constant. So for a uniform distribution, we are also interested in finding the mean. Okay, the mean for any variable that is following the uniform distribution is just given by, of course we know the mean is the expected value. It's given by 1 over 2 A plus B. Okay, and the variance of x is just given by 1 over 12 B minus A. Okay, so this is how we find the expected value and the variance. And for the probability, of course, probability for any values between, let's say, between C and D. So the probability is just given by that integral of f of x dx. And we know, of course, that f of x is 1 over b minus a. Okay, so let's have an example. In this example, we're told that suppose x is uniformly distributed over the range 2 less or equal to x less or equal to 6. Find the mean, the variance, and the probability that x is between 4 and 6. Okay, so we are supposed to find the mean, the variance, and probability that x is between 4 and 6. Okay, so let's begin with the mean. We know the expected value is just given by 1 over 2 A plus B. The range of the values is given as 2 and 6. So our A is 2 and B will be 6. Therefore, the expected value will be given by 1 over 2 plus 6, which just gives us 1 over 2 multiplied by 8, and this is 2 there, 1, 4. So 4 as our answer. Okay, the variance of x is just 1 over 12 b minus a. So this gives us 1 over 12, 6 minus 2. This will give us 1 over 12 multiplied by 4. 4 over 12, which is 1 over 3. Okay, so that is our variance. Let's find the probability that x is between 4 and 6. So to find this probability, we're going to have the integral between 4, just erase that, between 4 and 6 of f of x, and we know our f of x is just what? 1 over 6 minus 2 dx. Okay, so this integral 4. Please revise your integration. Revise your integration. 1 over 4 dx. So this just gives us 1 over 4. Actually, it gives us x over 4. So we replace first 6 over 4 minus 4 over 4, and it gives us 2 over 4, which is just a half. So this is how we find the probability. This is how we find the probability using the exponential, the uniform distribution. But because your integration is a bit poor, so on the uniform distribution, I will just ask you how to find the expected value and the variance. But please know the formula for f of x. Okay, so the next distribution that we look at is the exponential distribution. Okay, so we now look at the exponential. Okay, so this is also known as the waiting time distribution. Okay, so this is the other name. It is used to measure time that elapses between two occurrences. Okay, so the time between arrivals is known as lambda. So that is the time between arrivals, and the probability that an arrival time is equal or less than some specified time a. So that is just the probability that x is between x and a is given by the formula 1 minus exponential minus lambda a. So this is your formula for finding the probability. And in this case, our lambda there is the time between arrivals, and our a will be given from the question. Okay, remember that the distribution that measures the number of occurrences per time period is the Poisson. Number of occurrences per time period is the Poisson. But the distribution that measures the time between occurrences is the exponential. Okay, with mean time 1 over lambda. So the exponential is given by that function. This is our f of x and our x, so it's just given by that. So this is the function for the exponential distribution. So let's have an example. Customers arrive at a counter. Okay, so we have customers arriving. Customers arrive at a counter at a rate of 15 per hour. What is the probability that the arrival time between consecutive customers is less than 5 minutes? Arrival time is less than 5 minutes. Okay, so here we note that lambda again is the time between arrivals. So here you're told that you have 15 customers per hour. Okay, so now you want to know lambda in terms of minutes. Okay, you are told how many customers will arrive in less than 5 minutes. Therefore, we need to find lambda in terms of minutes. The one that you are given is 15 per hour. So let's now find lambda in terms of minutes. So it's 15 over 60, which just gives you 0.25 per minute. Okay, so that is our 0.25 per minute. Okay. So therefore, the probability that x is less than 15, probability that x is less than 5 will just be 1 minus e, of course this is the formula, lambda a. Our a in this case is 5. So therefore we have 1 minus exponential negative 0.25 times 5. Put that on your calculator. Your answer is supposed to be 0.7135. Okay, so this is how we find probabilities using the exponential distribution, also known as the weighting line distribution. So you'll be dealing with much of this when you do operations research, okay, or when you'll be talking about the weighting theorem. So the last distribution that we're going to look at is the normal distribution. So we're going to spend much of the time looking at the normal distribution. So this is the most common distribution. Okay, it is the most common distribution. One thing to take note about the normal distribution is that it is bell-shaped. Okay, it is bell-shaped and also symmetrical. Symmetrical just means it's like it has a mirror line. The other side is equal to the other. So this is how we represent the normal distribution. Okay, so these lines the endpoints, they don't touch the x-axis. Okay, now what is the PDF of a normal distribution? That is the probability distribution function, f of x. Okay, f of x is given by this formula, minus e to the power half x minus mu over sigma squared, then over square root of 2 pi sigma squared. Okay, so that just remove it. X minus mu. X minus mu. Okay, so this is the formula of the PDF of the normal distribution, and this implies that to find the probability we have to integrate this function. So this function doesn't look too good for you social scientists, okay, but it is actually very easy to do. Okay, So to find the probability, we said we have to integrate that formula. But remember, the probability for any continuous variable is just given by the area under the curve. Probability is given by the area. Okay, so therefore, if we have this, okay, then the probability, if we had A there and B there, then the probability is just the area, this area. If we can find it, then this will give us the probability. Okay, there are some important things that we mentioned about the normal distribution. We said it is symmetrical. So this implies that it is centered around the mean. Okay, my sketch here. So that point there in the middle, it is the mean. Okay. And the standard deviation just gives you this distance. This is the standard deviation. If you have a longer distance from the mean to where the curve, where you meet the curve, then it means that you have a higher standard deviation. But if you have a lower distance there, then it means that you have a smaller standard deviation. Okay. So we said it is symmetrical. So the other side is equal to what is on the left of the mu, the probability is equal to what is on the right of mu. Remember, the total probability is given by 1. So that means the area this side is 0.5 and the area on the other side is 0.5. Okay, so those are just some of the characteristics of the normal distribution. Okay, we move on. Move now to the standard normal. Okay, so the normal distribution can have any value of the mean and standard deviation. But for a standard normal distribution, this is also known as the Z distribution. So for this distribution, it is special because the mean, we assume the mean to be 0 and the standard deviation to be 1. So for a standard normal distribution, the mean is always 0 and the standard deviation is always 1. Okay, so now I have something like that, where on the middle there we have our mean, which is just 0, and this distance, which represents the standard deviation, is 1. Okay, so this is the special thing about the standard normal. The mean is 0 and the standard deviation is 1. Now, the values on the left of 0 are negative values. So these are known as negative Z values. And the values on the right will be positive Z values. Okay. So actually, any normal distribution with any mean and any standard deviation can be transformed. Any normal distribution can be transformed into the standard deviation. okay, can be transformed into the standard normal distribution using the following formula. So we use the formula for any x units, z is equal to x minus mu over sigma. So your x, which is just any normal distribution random variable, okay, and mu is the mean, sigma is the standard deviation. Okay, so let's have an example. So if x is normally distributed with mean 100 and standard deviation 5, x is normally distributed. With mean of 100 and standard deviation of 5. Find the z value for x equal to 25. To 250. X equal to 250. Okay, so let's solve this solution. Here we are given that the mean, which is mu, is 100 and standard deviation is 5. X is given as 250. Therefore, z, which is equal to x minus mu over sigma, will now be 250 minus 100 over so let's have our standard deviation to be 50. Okay, so let's have that as 50 over 50. So that 250 minus 100, 150 divided by 50, we get 3. So this will give us 3 as our z value. So this is how we transform any values. Okay, this is how we transform any values, nz values, any normal distribution values to the standard normal. Okay, so maybe let's just have another example. So to find, I said that to find the probability, we needed to integrate or to find the area. Okay, so actually that integration has already been done for us, and it has been presented on a standard normal table. Okay, so that has been presented on a standard normal table. Okay, so the next slide. Okay, so for the standard normal table, it gives us this probability. For any value between a and x, we know that the probability is given by this. Now this time we just have x squared, because remember the mu is 0 and the standard deviation is 1. So that is now simplified to that 2 pi dx. So there's some people who spent their time calculating these probabilities for us. They have tried between 1 and 2, what could be the probability? Between 2 and 3, they have integrated. Between 4 and 5, they have integrated and presented the information on a table. Okay, so that as we just need to go on that table to find the probability. Okay, so this is the next thing that we're going to do in the next part of this lecture. So in the next video, I'm going to show you how to read the normal table. Okay.